Good morning to all. Myself, Dr. P. Janagaratnam, Department of Mechanical Engineering, SNS College of Technology. In my previous video series, I already discussed about the different types of machines, mechanisms are incorporated in our mechanism of machines. Today, I am going to discuss about the new topic which is related to the kinematic diagram and inversions. So, what are the basic mechanisms are available and what are the basic inversions are implemented in our slider crank mechanism as well as the 4-bar chain mechanism and all. And now I am going to explain. So kinematic diagrams means first of all we have to take any kind of mechanisms. We have to apply the force means it maybe produce some of the velocity, acceleration and some other points like the rate of change of distance with respect to time, which is called known as velocity, the rate of change of velocity with respect to time, which is called known as accelerations. So this kind of angular acceleration and angular velocity which and all we have to calculate it by using this kind of kinematic diagrams. And what are all the kinematic diagrams? I already told, like simplified representations like graphical views of the mechanism showing links on joints and captures the relative motion of the individual links as well as the joints, and the crucial for motion paths and mechanical systems creation. And the kinematic chains and pairs, we means the assembly of rigid links connected by the specific joints, which is called known as kinematic chains, and the joints allowing defined relative motions like revolute and prismatic, this and all are called known as the kinematic pairs. So links, which is nothing but the movable combination of two joints. So the fixed link, the frame, and grounding the system. So one link is always fixed to the ground because we have to fix the base, then only we have to fix the other relative joints as well as the links. And defining the frame, the fixed component is known as the frame, and the motion impact choice of fixed links dictates the mechanism's behavior, because we have to fix one point as the arrest, because there is no degrees of freedom. Remaining all the links or the other joints will be withstanding the force which will be applied under the running conditions. So the base is the called known as frame. So what is the inversions of mechanisms? Mechanisms, already we have to discuss different types of joints, links are called known as combined together form a mechanisms. We have to do some modifications, means that is called inversion. So inversion is the process of fixing different links of the same kinematic chain at the time. Each fixed link choice creates a new mechanisms is called inversions. So that I already told, we have to simply modifying the fixed points and link position, means we have to do and implement the new mechanisms. So that is called known as inversions. So major inversions of 4-bar chain mechanisms are, so 4-bar already we have to discuss, like there are 4 links like crank, connecting rod, follower and base. So we have to do some modifications, means we have to implement this kind of new innovations like crank rocker mechanisms and double crank mechanism and double rocker mechanism. So one link rotates fully, another oscillate, means that is called crank rocker mechanisms. Two links rotates fully, that is called locomotive wheel engine mechanisms, that can be implemented in our trains also. And both the links are oscillated, like which is called known as oscillator mechanism. So these all are the 4 major 4-bar chain mechanisms and inversions. Next, what are all the slider crank chain inversion means? First one is for reciprocating engine mechanisms, and next one is for the connecting rod fixed and quick return mechanisms, and crossgate fixed oscillating cylinder engine mechanism, and slider fixed pendulum pumps mechanisms, and other varieties like fixed denoted points of the 4-bar mechanism, slider crank inversions. So these all are the different units. So next one is for the visualizing the kinematic diagrams, prediction motion, avoid the errors. So here now we have to use the relative motion method. We have to construct the both diagrams, and as well as the we have to use the computer aided tools, computer aided design softwares, which will be used to develop the this kind of designs also. So this is the practical applications like crank cracker, steam engine, pumps, engine compressor, locomotive wheel coupling, scotch yoke, and elliptical thermal mechanisms. So these are all the some of the harnessing inversions like analog designs, key designs, understanding the diagrams. Engineers can efficiently customize the motion and explore inversions of robotics, automotive, and manufacturing. So this is the mind map of this session, which will be entire summarization of to this entire PPT. So this is the two assessment questions which will be related to our today's topics. And this is the some of the reference we have to taken the other simulative tools as well as the kinematic diagrams as well as the mechanisms. So thank you. Next class we have to elaborately discuss about the velocity and acceleration diagram for the same slider crank mechanisms and other mechanisms. Thank you.